Everyone, this is Dr. Mama Ghazal, and today in this video we will talk about chemical kinetics. So, chemical kinetics is that branch of physical chemistry which deals with the study of the rate of chemical reactions, and such studies enable us to elucidate the mechanism by which a reaction occurs. So, when we are talking about chemical kinetics, basically we are talking about the rate of reaction is followed as time as a variable which is introduced. And there are many reactions for which the kinetics studies are not possible. Many ionic and explosive reactions occurs instantaneously, and in such cases, it is not easy to measure their rates. But special techniques have been devised to study their kinetics. So now first we will talk about the understanding of the meaning of chemical kinetics. So kinetic studies, why it is so important? It is important to understand the reactions and they also have a practical implications. It is utilized by scientists to determine the optimal conditions and variables required to speed up the reaction time of certain reactions. Chemical kinetics is an experimentally determined area of chemistry where no theories can determine the rate expression by just considering the chemicals involved. And it is not only important in industries, but they are also used to understand biological process, especially enzyme catalyzed reactions. Chemical kinetics also play a very important role in environmental and atmospheric chemistry as a part of an effort to understand a variety of issues ranging from the fate of prescription pharmaceuticals in wastewater to the cascade of reaction involved in the ozone cycle. Now in this, we are going to discuss about some of the major applications of chemical kinetics, which you can see easily without having doing any practical in laboratory. So the process of radiocarbon dating. Radiocarbon dating process is used to find the age of the very old fossil fuels. And this particular study is based on chemical kinetics because radiocarbon dating uses the naturally occurring radioisotope carbon 14, estimate the change of carbon bearing materials up to about 58,000 to 62,000 years old. Ozone layer depletion, which is a common one, and it is a negative effect of catalysis. So every time when we are talking about catalyst to enhance the rate of reaction, to diffuse the rate of reaction, to give the more good product. But here when we are talking about ozone layer depletion, so catalysts are not always the savior as they are thought of. Sometimes their acceleration of chemical reaction is also harmful. So one such example is your ozone layer depletion. They are catalyzed by chlorofluorocarbons and hence have caused a lot of environmental damage. So from this picture, it will be more clear that chlorofluorocarbon molecules are exhibiting UV or ultraviolet rays, and that ultraviolet rays causes a chlorine atom to break away from the chlorofluorocarbon molecules. Once it is splitted from that, then after that, the free chlorine atom hits on an ozone molecule. And in the third picture, you can see that the chlorine atom pulls one oxygen away. The free oxygen of atom hits the chlorine monoxide molecule, and that particular results in another free chlorine atom. So this free chlorine atom will continue to deplete ozone in the stratosphere as we are having lithosphere, troposphere, stratosphere. So stratosphere where the ozone layer depletion is taking place. Chlorofluorocarbons had also been used in refrigerants and air conditioners as a propellant in aerosol sprays because they were non-toxic and non-corrosive. But they work quite well for such purposes only. But in fact, when we are chemically talking about this chlorofluorocarbon working, so they are chemically unreactive and had very extremely negative side effects. Third application is prevention of food spoilage. Means prevention of food spoilage is also based on the principle of chemical kinetics. When you are putting your food in a refrigerator and you are actually using the principle of chemical kinetics. Spoilage of food, which is a very normal chemical process. food kept under room temperature provides an ideal condition for enzymes present to catalyze reactions with oxygen present in the air, and that spoils food. When cooked food is stored in refrigerators under lower temperature, Arrhenius equation tells us that a reaction rate increases when the temperature increases. If we reduce the temperature, the rate of reaction will also reduce. So when we store the food at low temperature, the rate of its spoiling also reduces. And this is the equation of your Arrhenius one. Now we are going to talk about what kind of a reactions can be considered under study when we are using chemical kinetics. So according to that, some reactions are slow, some are fast. So for example, if I'm talking about the rusting of iron process, or iron combines with oxygen in a presence of air when it rusts, which is a slow process or a slow reaction. While a piece of phosphorus, when exposed to air, bursts into flame, this is said to be the spontaneous or a fast reaction. So the chemical reactions are said to proceed at different rates. Fast reactions, another some examples are precipitation of silver chloride when solution of silver nitrate and sodium chloride are mixed, neutralization of an acid with a base when their aqueous solution are mixed like HCl plus NaOH, which is forming NaCl and water. Slow reaction examples, reaction between hydrogen and oxygen at room temperature, reaction between carbon and oxygen at room temperature, and carbon and oxygen are thermodynamically less stable than carbon dioxide at 298 Kelvin. So the rate of fast reactions and its kinetics cannot be studied, but the study of kinetics is limited to the slow reaction process, where means it can be studied easily and to identify the order of that particular reaction. Now, the general definition of a reaction rate. So, reaction rate or a rate of reaction tells us what speed the reaction occurs. Here we are taking and considering a very simple example, A to B. A is said to be your reactant and B is your product. So, the concentration of reactant A decreases and the concentration of product B increases as time passes. So we can say that the rate of reaction is defined as the change in the concentration of any of the reactant or a product per unit time. So for the given reaction of the rate of reaction, which may be equal to the rate of disappearance of A, which is equal to the rate of appearance of B. So the rate of reaction can also be calculated in the terms of rate of disappearance of A is equals to the rate of appearance of B. Now, the units of rate of reaction, in which units actually we are calculating the rate of reaction. So, rate of reaction has the unit of concentrations, which is divided by time. So, usually we are expressing concentrations in moles per liter, but time may be given in any convenient unit like seconds, minutes, hours, days, or possible years. Therefore, the unit of reaction rates may be mole per liter second, mole per liter minute, mole per liter hour, and so on. Now we are going to talk about rate law or rate constant. So by studying numerous of reactions, it is shown that the rate of reaction is directly proportional to the reactant concentration, and each concentration being raised to the some power. So if I'm taking under consideration a substance A undergoing a reaction, so the rate is directly proportional to A raised to the power n, and rate is equals to Ka raised to the power n. So the power of the concentration n or m in the rate law is usually a small whole number integers like 1, 2, 3 or fractional, and the proportionality constant K is called the rate constant for the reaction. For a reaction 2A plus B, it is giving you a product. So the reaction rate with respect to A or B is determined by varying the concentration of one reactant, keeping the other concentration of the reactant constant, and the rate of reaction may be expressed as rate is equivalent to Ka raised to the power m and B raised to the power n. So the expression which shows the reaction rate is related to the concentration is called the rate law or rate equation. So I'm ending this video, and in my next video we will talk about the order of reactions. If you like my video, so please do subscribe my channel, share and like it. Bye for now.